plane uses the Earth's atmosphere to keep it in the air while flying. But further away from the Earth, the atmosphere is thinner and thinner, so regular flying mechanics would not work. So, how does a rocket manage to accelerate forward in space even without air present? A rocket engine burns fuel that gets shot out the back at very high speeds. These gases take advantage of Newton's third law, which states that for every action force, there's an equal in magnitude and opposite in direction reaction force. So the force that pushes the gases out the nozzle is equal to the force that's being pushed on the rocket. For example, when you blow up a balloon and then let it go so it moves around the room all crazy, that is the same idea as what the rocket does. It shoots out gas that causes it to move forward. Let's take a look at the engine. Rocket engines use a chemical reaction to propel forward. It needs fuel and an oxidizer. These are called the propellants. Typically, a rocket uses either liquid or solid propellants, but there are also hybrids. There are advantages and disadvantages to both. Solid propellants are used in the firecrackers and typically at the start of a rocket's launch. Here's a poorly drawn image of a solid propellant rocket. The fuel and oxidizers would be stored here and be released into the chamber. There would be something to ignite the mixture, which would cause a rapid chemical reaction to take place, causing the newly formed gas to shoot out the other side. Proper mixture of fuel and oxidizer is crucial in order to prevent the rocket from exploding. Solid propellants are usually simpler in design, but it is harder to control the rocket once the fuel starts burning. Therefore, using liquid propellants, it's a lot more complicated. The fuel and oxidizers are kept separate from each other, and you're able to control how much is let in at a time. This gives more control to the rocket. These liquid gases also have to be stored in high pressure and low temperature containers, which causes more complications. Here's an oversimplified diagram of a liquid propellant rocket. The liquid oxygen and liquid fuel are held in separate isolated containers. They would then be pumped into the chamber where the reaction would take place. Common fuel for a liquid propellant rocket is liquid oxygen, uses an oxidizer, and liquid hydrogen or kerosene uses the fuel. A rocket will usually have a multi-level propulsion system, which just means it has multiple boosters to it. Once the first booster runs out of juice, it is let go and another booster starts up. These boosters don't all have to be the same type. For example, the first one could be a solid rocket, while the next one is a liquid rocket. Only multi-stage rockets have ever made it into orbit before, so typically most rockets are multi-level systems. The goal of most rockets is to bring a satellite into orbit, and in order to do that, it has to reach a critical velocity depending on the amplitude above the Earth. This velocity is known as orbital speed. Orbital speed is dependent on how far from the Earth the rocket needs to go. For example, 35,000 kilometers away, and the orbital speed is about 11,000 kilometers an hour. Once a satellite is in orbit, it will not need a rocket to propel it around the Earth. The Earth's gravitational pull will cancel out with the perpendicular velocity of the satellite, causing it to rotate around the Earth without human interference. That being said, sometimes the satellite's orbit may need to be altered. Typically, ion repulsion systems are used, which is a device that uses the same principles from the rocket, but instead of a chemical reaction, ions are accelerated by electrostatic forces and then shot out the satellite. Usually xenon is used, which is element number 54. It is used due to its high atomic mass and easy ability to ionize. Let's take a look at an ion repulsion system. At first, xenon is brought into a chamber. Electrons are then shot at it at very high speeds. This is known as electron bombardment, and it causes the xenon to lose electrons, which makes it positively charged. The positively charged xenon is then accelerated in an electric field, which causes it to go at very high speed. It is then shot out the back of the chamber at very high speeds. This causes the satellite to move backwards, just like before with the rocket. Electrons are then shot at the xenon to neutralize it. If a rocket is escaping Earth's orbit, then it will require more complicated considerations, which I'll talk about in another video. If you enjoyed, please like and subscribe, and let me know what you'd like to see next.